Hello everyone. Today we will be going over adding and subtracting rational expressions, and we will start with like denominators. Okay, so remember, if you go back to your regular, ordinary, everyday fractions, if you have P over Q plus R over Q, something over Q plus something over Q will give you an answer over Q. Okay, so really you just add or subtract your numerator. In this case, it will be P plus R over Q. Alright, so let's say, for example, you have 5 over 8 plus 2 over 8. Something over 8 plus something over 8 will give you an answer over 8. Okay, so now you just add your numerator, 5 plus 2, so you have 7 over 8. Okay, remember you do not add or subtract your denominators. Okay, the goal is to get the same denominator and then add or subtract your numerators. Alright, so let's say, for example, if we wanted to add x over 9 plus 3x over 9. Okay, the exact same thing. We have the same denominator. So that means our x over 9 plus 3x over 9. Since we have the same denominator, our answer will be something over 9. Okay, so now we just go ahead and add our numerators. So you have x plus 3x. Oh, sorry about that. X plus 3x. Which, once you combine those two, you get 4x over 9. Alright, so what if we had the example where we needed to add 4t minus 9 over 9t plus 7 over 9t. Alright, so we will just rewrite this plus 7 over 9t. So we have the same denominator. So that means something over 9t plus something over 9t will give us something over 9t. So now we just add our numerators. So you have 4t plus 9. Oh, 4t minus 9, sorry about that, plus 7. 4t minus 9 plus 7. Alright, so if you notice here, I put a parenthesis around this first numerator. Okay, because remember, you're adding this entire numerator to this entire numerator. Okay, it's not so important with addition, but with subtraction, these parentheses can be very, very important and can really make a difference between the right answer and wrong answer. Okay, so what I do, I suggest you use parentheses for both just to get into a very good habit. Okay, now since this is positive, you can kind of drop the parentheses there. So you have 4t minus 9 plus 7 all over 9t. Alright, so we can go ahead and combine those two terms. Okay, so you have 4t, negative 9 plus 7 is negative 2, so 4t minus 2 all over 9t, and it doesn't simplify anymore, so that's your final answer. Unless you want to factor out a 2, which you can, but you don't have to. Alright, now also remember, you have two terms up here. Your denominator is factored, your numerator is not. You have two separate terms, so you can't cancel out the t's. You can only do that when it's multiplication. Okay, so this is multiplication. These two terms is subtraction. It's not multiplication up here, so you can't cancel those t's out. Alright, so let's go ahead to the next example. Alright, bring that back down. There we go. Alright, so let's say, for example, if we wanted to subtract x squared plus 10x over x plus 3 minus 4x minus 9 over x plus 3. Okay, so this will show you kind of the importance of parentheses. Alright, so I'm going to go ahead and just do a quick rewrite. X squared plus 10x over x plus 3 minus 4x minus 9 over x plus 3. Okay, so you have something over x plus 3 minus something over x plus 3, so that's going to equal something over x plus 3. Okay, so that part we have figured out already. So now we just go ahead and subtract our numerator. So you have this entire numerator, so that's x squared plus 10x minus this entire numerator. Okay, so if you just put minus 4x minus 9, you would get an incorrect answer. Okay, because you're subtracting that entire numerator. So that's why the parentheses are very important. Okay, so now you go ahead and get rid of the parentheses. This is positive, so this is just x squared plus 10x. This you're going to distribute kind of like a negative 1. So negative 1 times 4x is negative 4x. And negative 1 times negative 9 is positive 9. All over x plus 3. See, if you didn't put the parentheses there, you have the correct minus 4x. But if you left that as just minus 9, you wouldn't get the correct answer. Alright, so now we go ahead and combine our like terms. So we have x squared, 10x minus 4x is positive 6x, plus 9 over x plus 3. Okay, now the one thing you want to do, even when it looks like you're done, is always factor your final answer. Because you never know when something may cancel out. Okay, so if you realize that x squared plus 6x plus 9 actually factors into x plus 3 times x plus 3. Okay, so that gives us x plus 3 times x plus 3 all over x plus 3. And if you want, you can make it 1 times x plus 3. Okay, so this x plus 3 cancels with either one of those, doesn't matter. And that leaves you with x plus 3 over 1. Anything over 1 is just that value, so that's just x plus 3. Okay, so that's why it's important to remember those parentheses. Alright, so let's go ahead to our next example. If you're still writing, feel free to press pause. Alright, so let's say for our example, if we want to subtract x squared over x plus 7 times x plus 8 minus negative x squared plus 14x over x plus 7 times x plus 8. Alright, so what I want you to do is go ahead and press pause, and I want you to try to solve this one on your own. Alright, so I'm assuming you have pressed pause, you have worked everything out, and you are all set. So I'm going to go ahead and rewrite the problem. X squared over x plus 7 over x plus 8 minus negative x squared plus 14x over x plus 7 times x plus 8. Okay, so I just rewrote it. So that means since we have x plus 7 times x plus 8 here, and x plus 7 times x plus 8 here, our answer is going to be something over x plus 7 times x plus 8. Okay, so now we're just going to go ahead and subtract our numerators. So you just have one term here, so you don't really need parentheses for that one. So you have x squared minus negative x squared plus 14x. Because remember, you're subtracting that entire second numerator. Okay, so now we can go ahead and distribute that negative. Okay, so that's going to equal, you have your x squared. Negative 1 times negative x squared is positive x squared. Negative 1 times positive 14x is negative 14x. All over x plus 7 times x plus 8. Okay, so now we can go ahead and combine our like terms. So x squared plus x squared is 2x squared. So we have 2x squared minus 14x all over x plus 7 times x plus 8. Okay, so really if you look closely at these two terms, you can factor a 2x out of both of those. So factor out a 2x. So if we factor out a 2x, that leaves us with 2x times x minus 7 all over x plus 7 times x plus 8. Okay, so we can see here, x minus 7 and x plus 7 do not cancel each other out. They're not the same thing. Since they don't cancel out, we can go ahead and say this is our final answer. Okay, now sometimes when you factor, it cancels, and sometimes it doesn't. Okay, but it's always best to factor at the very end just to see if something will cancel out. Okay, better safe than sorry. All right. So if you're still writing, feel free to press pause, but we're going to go to our next step, which would be adding and subtracting rational expressions, this time with different denominators, unlike denominators. Okay, so those require a little more work. Alright, so these are your steps for adding and subtracting with different denominators. Okay, so the first step, you want to factor your numerators and denominators if necessary. There are some times where you won't have to factor them. They're as factored as they're going to get. You can skip step 1 for those problems. Okay, your second step, you want to find the least common denominator by matching your denominators. And I'll show you what I mean by that when we do our examples. Okay, then the third step, because the second step is going to give you your like denominators. Your third step is you're going to add or subtract your numerator over that common denominator and simplify if possible. It won't always be possible to simplify, but you always want to try. All right. So if you're still writing, please feel free to press pause. But for now, we're going to go to our first unlike denominator example. Excuse me. All right, so let's say, for example, if you want to add 9x over 7 plus 3x over 5. All right, so we can see that everything's already factored. The numerators and denominators are already factored, so you can skip that step. Okay. Now your second step, find your least common denominator. Okay, so we know that the least common denominator between 7 and 5 is 35. Okay, that's the smallest multiple that they have in common. Okay, so if you count by 7, 7, 14, 21, 28, 35, that's the first time you have a value that's a multiple of 5. So that's your least common denominator. So that means our 9x over 7 plus 3x over 5, we want to somehow change this 9x over 7 into something over 35 plus something over 35. So we want to get both of those denominators to equal their least common multiple of 35. All right, so we know that 7 times 5 is 35. So if we multiply 7 times 5, we'll get our 35. But whatever you do to the denominator, you have to do the same thing to the numerator. So you have to multiply that by 5 also. Okay, same thing over here. We know that 5 times 7 is 35. But whatever we do to the denominator, we have to do the same to the numerator. So it's 7. Okay, so we have 5 times 9x, which is 45x, plus 3x times 7 is 21x. Okay, so we have our like denominators. So something over 35 plus something over 35 is going to equal something over 35. And really all we have to do is just add our numerators. So we have 45x plus 21x, which would give us 66x over 35. Okay, now there's nothing that would cancel out between those two, so that would be our final answer. All right, hopefully that made sense. So we'll go to our next example. And this one will test just how much you paid attention on the last video. So what if we add 2 over x minus 2 plus 10 over 2 minus x. Okay, so if you paid attention to the previous videos, this would look familiar. Okay, and the reason it would look familiar is because if you have 2 over x minus 2 plus 10 over 2 minus x, you would remember that 2 minus x, if you factor out a negative 1, you could switch those two around to x minus 2. Or you can do the same thing with x minus 2. If you factor out a negative 1, you can have a negative 1 times 2 minus x to match it that way. Okay, so that's going to equal 2 times x minus 2 plus 10, and our 2 minus x, we can make that negative 1 times x minus 2. So we have negative 1 times x minus 2. Okay, now remember, that negative 1 can be in the denominator, you can move it up to the numerator, or you can move it up front, it doesn't matter. So you have 2 over x minus 2 plus negative 1 times 10 over x minus 2. Okay, so we have our common denominator. Move that up a little bit. So something over x minus 2 plus something over x minus 2 will give us something over x minus 2. Okay, so that would just give us 2 plus negative 1 times 10. 2 plus negative 1 times 10, which gives us 2. Negative 1 times 10 is negative 10, so 2 minus 10 over x minus 2, or just negative 8 over x minus 2. Alright, so hopefully you're keeping up so far. Okay, so let's go to one that's a little more complicated, but the exact same steps. Alright, if you're still writing, feel free to press pause, but we're going on now. Move that down, there we go. Okay, so let's say, for example, we want to add 6x over x squared minus 4 minus 3 over x plus 2. Alright, so I'm just going to do a quick rewrite over x squared minus 4 minus 3 over x plus 2. Remember, your first step is to factor all your numerators and denominators. The 6x, the 3, and the x plus 2, they're as factored as they're going to get. But this x squared minus 4, remember, that's just x squared minus 2 squared, because it's a difference of squares. So that's just x plus 2, x minus 2. Okay? So we know that this will give us 6x over x plus 2 times x minus 2 minus 3 over x plus 2. Okay, now this is where we go to step 2 and we match our denominators. Okay, so now we have to have the same thing in each denominator. So we have an x plus 2 here and an x plus 2 here. So that's good. Now we have an x minus 2 here, but no x minus 2 over here. So we know this side is missing an x minus 2. Alright. Well, it's real easy because all we have to do is multiply the x plus 2 times x minus 2, but on this side. Okay, so we have 6x over x plus 2, x minus 2, minus 3 over x plus 2. Then we just multiply the denominator by x minus 2. But remember, anything you do to the denominator, you have to do it to the numerator. So you have to multiply this one by x minus 2 also. Okay, so we have x plus 2, x plus 2. We have x minus 2 in the denominator. Okay, so we're good to go. We have matching denominators. So that means our answer is going to be something over x plus 2 times x minus 2. So really, the only thing left is just to subtract our numerators. Okay, so you have 6x minus 3 times x minus 2 is all one term. This is just 3 times another times a polynomial. So you don't need parentheses around that whole thing. I mean, if you put them there, it wouldn't hurt, but you don't need to because it's just one term. Okay, so now we go ahead and distribute our -3. Okay, so we have 6x. -3 times x is -3x. -3 times -2, oh, +6, sorry about that. All over x plus 2, x minus 2. Alright, so now we go ahead and combine those two terms. Move this up a little bit. Okay, so 6x minus 3x is 3x. Plus 6 all over x plus 2, x minus 2. Now remember, when it looks like you're done, factor your final answer to see if anything can cancel out. That's very important. Alright, because if you look at these two terms, you can factor a 2 out of both of those. I mean, factor out a 3. So that gives us 3. 3 times x will give us 3x. And 3 times 2 will give us 6. All over x plus 2, x minus 2. And just that simple act of factoring out a 3 allowed us to cancel this x plus 2 and that x plus 2. Which gives us our final answer of 3 over x minus 2. Okay, so that last minute canceling is very important. Alright, so let's go ahead to our next example. Okay, so for example, let's say if we want to add 2 over 3 times t plus 5 over t plus 1. Okay, so for this one, I want you to press pause and give this one a try on your own. Alright, so assuming you've pressed pause and you're ready to go, we're going to go ahead and solve this one. Okay, so I'm just going to rewrite it. 2 over 3t plus 5 over t plus 1. They're already factored. You can't factor these down any more than they already are, so you can skip that first step. Okay, so now you want to go to your second step where you want to match your denominators. And this t plus 1, we're going to go ahead and put that in parentheses. Okay, so we see here you have a 3 on this side, but you don't have a 3 here. So this one's missing a 3. You have a t on this side, but you don't have a t on this side, at least not a factor. You have a t plus 1, but you don't have a t. So you're missing a 3 and you're missing a t. If you want, you can just make it 3t that you're missing instead of doing both of them separately. Okay, now if you look on this side, you have a t plus 1. But this side, you're missing a t plus 1. Okay, so if we rewrite it, I'm going to give it a little bit of space. So you have 2 over 3t plus 5 over t plus 1. Since we're missing a t plus 1 over here, we just multiply this by t plus 1. But whatever you do to the denominator, you have to do it to the numerator. So you multiply this by t plus 1, the numerator. Okay, so same thing over here. We're missing a 3 and a t over here. So we can solve that by multiplying the denominator by 3t. But of course, whatever you do to the denominator, you have to do it to the numerator also. Multiply that one by 3t. Okay, so you have a 3 here, a 3 here. You have a t here, a t here. You have a t plus 1 and a t plus 1. So we're matching on both sides. Okay, so that means 3 times t plus 1, well, something over that plus something over 3 times t plus 1 will give you something over 3 times t plus 1. Okay, that's our common denominator. So now we just go ahead and add our numerators. So you have 2 times t plus 1, and you could have left it 2 times t plus 1 times 2. It would have given you the same answer. I'm just really quirky about that. Plus 5 times 3t. All right. So now we go ahead and simplify our numerator and see exactly what we end up with. So we go ahead and distribute that 2. 2 times t is 2t. 2 times 1 is 2, so that's plus 2. Plus 5 times 3t is 15t, so plus 15t, all over 3t times t plus 1. Alright, so if we look carefully, we can combine those two terms in our numerator. So 2t plus 15t is 17t. Plus that 2, can't forget that, all over 3t times t plus 1. Okay, so there's nothing we can factor out of those two terms in our numerator, and nothing cancels out, so that would be our final answer. All right. Okay, so let's go to our next example. Okay, and this is more of a, just to expose you to a little trick problem they may throw at you. So let's say if we wanted to add 1 plus x over x plus 1. Oh, straighten up, there we go. Okay, now believe it or not, when you have a rational term and you add or subtract a whole number, that's probably the easiest problem you're going to run across. Okay, the reason is you want to remember that any number divided by itself is equal to 1. So 1, you can make that equal anything you want. And since the goal is to get common denominators, you can make 1 equal x plus 1 over x plus 1. Okay, so you immediately have a common denominator because our 1 plus x over x plus 1, that 1 became x plus 1 over x plus 1 plus, and this one just stays the same, x over x plus 1. Now remember, if this would have been x minus 2, you could have made 1 equal x minus 2 over x minus 2. If this denominator would have been x minus 80, you could have made 1 equal x minus 80 over x minus 80. Okay, so you automatically have your common denominator as soon as you see that 1. So those are really your easier problems, as long as you remember that little trick. Okay, so we have something over x plus 1 plus something over x plus 1 will equal something over x plus 1. Okay, so now we go ahead and add our numerators. So we have x plus 1 plus x. Alright, so this is positive, so we can drop the parentheses there. So we have x plus 1 plus x over x plus 1. Okay, so if we go ahead and combine those two terms, x plus x is 2x. So we have 2x, don't forget our 1 right there, plus 1 all over x plus 1. Okay, now remember, these are two terms in the numerator and denominator. It's not factored. Factored is when you have just multiplication. So you can't cancel out these x's and you cannot cancel out those 1s. Okay, so this is actually your final answer. 2x plus 1 there, over x plus 1. Alright, so hopefully that made sense. And just as a quick little hint, if you had something like, let's say if you had 5 plus x over x plus 1, then all you'd have to do is make 5 equal 5x plus 1 over x plus 1. Okay, because remember the x plus 1s, if they cancel out, it's just 5. So no matter what number is there, you can always make it equal the same. So it would still come up to the same steps. Okay, just a little heads up. Alright, so let's go to our next example. Okay, so let's say, for example, if we want to add 2x over x squared plus 2x plus 1 plus x over x squared minus 1. Alright, and what I want you to do is press pause and give this one a try yourself. Alright, so assuming you have pressed pause and you have worked everything out, we are going to go ahead and solve this one. Okay, so since we have 2x over x squared plus 2x plus 1 plus x over x squared minus 1. Remember, your first step is to factor everything. So the 2x is already factored, so you're good there. But x squared plus 2x plus 1 we know that factors into x plus 1 times x plus 1. Okay, and our x squared minus 1, remember that's just x squared minus 1 squared. It's our difference of squares. So that would just be x plus 1 times x minus 1. Okay, so if we rewrite it with our factored numerators and denominators, 2 times x is just 2x. That can't be factored any more than that. X squared plus 2x plus 1 is x plus 1 times x plus 1. Plus x can't be factored anymore. That's just x. We know our x squared minus 1 is x plus 1 times x minus 1. Okay, so now we go to our second step. Okay, so this was our first step. We go to our second step and we match up our denominators. Okay, so we look at it, we have an x plus 1 here and an x plus 1 here. So we're good there. Okay, we have a second x plus 1 here, but we don't have a second x plus 1 there. Okay, so we're missing an x plus 1 over here. Let me clean that up a little bit, make it a little clearer for you. We're missing our x plus 1. Okay, now if you look on our second term, we have an x minus 1 here, but we don't have an x minus 1 here. So we're missing our x minus 1. Okay. So our second step here is we're going to now match up our denominators. Okay, so if we have our 2x, I'm just writing the original problem, 2x times x plus 1, x plus 1, plus x over x plus 1 times x minus 1. Okay, since we know this term is missing an x minus 1 in the denominator, we just multiply this by x minus 1. But we already know anything you multiply to the denominator, you have to do the same to the numerator. So we multiply our numerator times x minus 1 also. Okay, so now we go to this term, we see here that this term is missing an x plus 1 in the denominator. Okay, so we can go ahead and multiply that by x plus 1. But once again, anything you do to the denominator, you have to do it to the numerator. So we multiply that by x plus 1. Okay, so let's double check our denominator, make sure we have everything. So we have an x minus 1 here. We have an x minus 1 here, so we're good there. We have an x plus 1 here. We have an x plus 1 here. So we're good there. Okay, so we have another x plus 1 and another x plus 1. So we're good there. So our denominators match up. So that means our answer will be something over x minus 1, x plus 1 times x plus 1. Because that's our common denominator. Okay, so now all we have to do is add our numerators. So you have 2x times x minus 1 plus x times x plus 1. Okay, so as soon as we distribute our 2x, and then we're going to distribute our x. Okay, so 2x times x is 2x squared. So we have 2x squared. 2x times negative 1 is negative 2x. Plus x times x is x squared. X times 1 is x, so that's plus x all over x minus 1, x plus 1, x plus 1. Okay, so now we can go ahead and combine our like terms. So we can combine those two since they're both x squared. And we can combine those two since they're both x. Okay, so 2x squared plus x squared is 3x squared. Negative 2x plus x is negative x. All over x minus 1, x plus 1, x plus 1. Okay, if you look closely here, you can factor an x out of both of those terms. Alright, since you can factor an x out of both of those terms, let me write out factor out x in each of those terms. Okay, so we factor out an x. X times 3x will give us 3x squared. And x times negative 1 will give us negative x. So you have 3x minus 1 over x minus 1, x plus 1, and x plus 1. Okay, so if you look closely, that 3x minus 1 doesn't cancel out with anything here. That x does not cancel out the x minus 1, x plus 1, or the x plus 1. So since nothing can cancel out, that is our final answer. Okay, so hopefully that made sense. And I will see you on the next video.